Measurement of volume of liquids. The volume of liquids is generally measured in liters, symbol L. The submultiple of 1 liter is milliliters, symbol ml. So liters.
Why do in some units write the units like kg in capital letters and like not this one, like Newton we write in capital letters but the liters we don't write in capital letters? Is it because of scientist name?
No, I don't know why this is used, so I'll check it later. I think it's just a symbol used in the very beginning, so we are just following that. Okay. Now first, we have what we have got, the volume of solid object. Till now, solid object like this, like this. Now we have to find out the volume of liquid. When you buy a water bottle, what do you see? Generally, how much water is there? In which unit? You see it? 1 liter. 1 liter bottle, 750 ml milliliter, 500 ml milliliter. Okay, in water, because we are measuring liquid, the volume of liquid. That's why you use milliliter or liter. That is more convenient. 1 liter is equal to 1000 ml. Remember this. Why you should use this highlighter here. One milliliter is also equal to 1 cubic centimeter or 1 cc. Understand? Cubic centimeter. This is also important. 1 milliliter is 1 cubic centimeter. Means in a dice, in a box of size of dice, how much water can be stored?
1 milliliter.
1 milliliter cube. 1 milliliter. Okay. So 1 liter is equal to 1000 ml. 500 ml means how much liter? Half liter. Half liter is equal to 1000 cc. Look at this three relations, is very important. 1 meter cube 1000 liter means 50 bucket of water, 1 meter cube. 1 liter is equal to 1000 ml. 1 liter is equal to 1000 centimeter cube.
How much is 1 milliliter?
How much is 1 milliliter? Have you seen the syringe, injection syringe? To tell, generally the smaller one contains 5 milliliter. There are some marks are there. 1 ml, 2 ml, 3 ml. In a syringe, it contains 5 ml. So it's very, very small amount, 1 milliliter. If a syringe can have 5 ml only, here you can consider it's almost, it will have almost 10 ml. If I am not wrong, 10 to 15 ml this bottle contains. Understand? 10 to 15 ml. So 1 ml will be this much. 1 ml. This much. Only this much will be 1 ml. Okay? So these relations are very important. 1 liter is equal to 1000 ml is equal to 1000 cc or 1000 centimeter cube. 1000 milliliter is equal to 1000 centimeter cube. You understand what is 1000 centimeter cube? 1000 centimeter cube can be written like here. 10 centimeter, this much. 10 centimeter this much. Okay, 10
But this is
centimeter,
a
10
rectangle,
centimeter,
not a square.
10 centimeter, 10 centimeter high. So like this. So it is, look at this box. Give your ruler, please. This one. No? How much centimeter here? It is 11 centimeter. Mark this. Okay. This 11 centimeter. We'll find the volume of this. 11 centimeter here. Okay. Next, what is the bread?
Height.
What is the bread? What is the bread? 8.5.
9.
Okay, 9 centimeter into what is the height? 12 centimeter. What will be it? 99 into 12. So 9, 8, 8. Is it okay?
cm.
Okay, 8 cm cube. Means if 1 liter is equal to 1000 centimeter cube, 1000 centimeter cube, you have got this 1000 centimeter cube. Can it hold 1 liter of water? If you pour 1 liter bottle of water here, it can store that 1 liter of water because its size is slightly greater than 1000 centimeter cube. So can you imagine what is 1 centimeter, 1000 centimeter cube? This is almost 1000 centimeter cube. Just like this. It may be one liter. It can hold 1 liter of water. It can hold 1 liter of water. This size. Just remember forever. So this is the size of 1000 centimeter cube. Remember, this is very important. I will not say it again. What is 1 centimeter cube? This is the relation. This question is asked on these relations. Never be confused. Remember the actual examples I have given. To have 50 buckets of 1 centimeter cube. 1 milliliter is, if this is 15 milliliter, 1 milliliter will be this much. 1000 centimeter cube means like a box of size this. This can hold 1 liter. Okay. Remember these things, then it will be easy for you. Now, 1 liter is equal to 1000 ml or 100 cc, 1000 cc or 1000 centimeter cube. Centimeter cube, it can be right. Like 1 liter is equal to 1 meter cube is equal to how much?
1 million.
It is easily 10,
1 million.
ones, tens, thousands,
Hundred.
hundreds, thousands,
10,000.
10,000s,
Lakhs.
100,000s, then 1 million. In SI unit.
Ones, tens, hundreds, thousands, 10,000, 100,000, 1 million.
1 million. 1 million cm cube. So 1000, 1 cm cube is equal to 1 ml. Okay. Cm cube can be written as milliliter. 10 lakhs or 1 million milliliter is equal to 1000 liter. Can you understand this? Just using manipulating the units here, this here. So 1 meter cube is equal to 1000 liter. Already here it is written. Again, they have proved from that very beginning concept. The volume of a liquid is measured. So if I understand 1 meter cube is 1000 liter. They have proved from this formula. 1 liter is equal to 1000 milliliter. From this, they have proved that 1 meter cube is equal to 1000 liter. Okay. Just work out some problems, then it will be clear for you. The volume of a liquid is measured using a container of known capacity. The space or volume inside the container is known as its capacity. How do we measure milk? There is a container. We have mug of 1 liter. We have cup of 250 ml. So you can measure volume of liquid with those containers. Okay. The mug has the capacity of 350 milliliter. Okay. So we can measure this milk with the help of this container cup. What is the capacity of this container? 350 ml. If you pour more than 350 milliliter, it cannot store. It will spill. So if we put more than 350 ml of water here, it will spill up. So the capacity of this mug is 350 ml. So maximum liquid that can be stored in a container is called the capacity. Here is the capacity. For measuring the volume of liquids, different kinds of measuring vessels are used. Some of these vessels are shown in figure 1.8. To find the volume of a given liquid, it is poured in the graduated cylinder. The volume of liquid is read from the level of free surface of the liquid in the graduated cylinder. However, if
liquid has only one free surface.
Oh, that free surface where suppose you pour liquid here, suppose it's come to 50 ml, that's the free surface. Okay, what will be the volume? 50 ml. These are the measuring vessels. However, if you observe the level of liquid carefully, it is not flat. If you see the liquid in your glass, when you drink water, look at the surface carefully. It's slightly bent towards the side.
Bent towards the side.
Side of the glass wall. In case of liquid which wet the side of graduated cylinder, such as water, alcohol, etc., the level is concave as shown in figure 1.9, like this, slightly bent towards the side of the container. Where should we keep our eye? Here or here? We must keep our eye level just in line with the lowest level of concave surface. Where we should keep our eyes, lowest level of, here is the lowest level. Okay, here we have to find out the mark. Such as where? Such as water and alcohol. Here it's look like this. If we keep eye level above the lowest level of concave surface, then we are likely to read more volume, is not it? If you see here, then we'll consider extra volume because water is not filled up to here. Similarly, if we keep the eye level below the lowest level of concave surface, we are likely to read lesser volume. Then if you see here, then we will measure less volume. Some liquids like mercury do not wet the sides. Do not wet. Here, alcohol and water, what?
Wet the sides.
Wet. It does not wet. It does not get attached to the container. They form a convex free surface rather than a concave one as shown in figure 1.9b. Here, mercury or what is this? Only mercury is given here. Mercury always convex like this. In such liquids, the eye level should coincide with the uppermost point of the convex surface. Okay, in this case, your eyesight should be coincide with this point, and here your eyesight should be to the bottommost point, lowest point. Measurement of volume of irregular solids by measuring cylinder. Irregular solids by measuring cylinder. Irregular volume.
solids.
Yeah. Irregular solids. How can I measure this? This is a irregular solids. Here this is. This is also an irregular solid. This is an irregular solid. Can it be measured by a cylinder? Is it possible? No? Let's see. Can it be measured? It can be measured. Take a measuring cylinder and almost half fill it with water. By keeping the eye at the lowest point of concave surface, record the volume of the water. Let it be x cc. Suppose this much. Just we fill the water. Now tie the given solid to a fine cotton thread. Fine cotton thread, very small cotton thread. Tie the object. Or given solid. Lower the solid gently on water so that it is completely immersed in water. The level of water in the measuring cylinder will rise as stone displaces water equal to its own volume. Here it is given as stone and here it is given as solid. Okay. Okay, let's consider solid. Will rise as the solid displaces water equal to its own volume. If you immerse this object here, it will replace water. How much it will replace? Equal to the size of its volume. Is not it? Okay. If you pour this in water, it will displace this much of water equal to this object. If it is displaced this much of water, then water level will rise. Record the new volume of water. Before it was x here, now it is y. See.
But we can also fill the whole cylinder if the marking is to its top,
Yeah.
and if we fill it and we like dip this bottle inside, so we can also get its value.
Yeah, we can find it. It is. You have to be careful in measuring this. You have to have fill. It is depend upon the object, which volume you are going to measure. Okay. So now let it be see. It is increased. It gone to C. Now the volume of the stone will be the difference between the second volume and the first volume. Volume of the stone 1 minus x is equal to cc. Understood? Very simple.
Is equal to cc.
Y minus x cc, centimeter cube, or whatever, a milliliter, whatever it is. It is milliliter, you will find a milliliter. Understood now what is the concept? Whatever. So cylinder, you can measure the volume of irregular object in a cylinder. To find volume of irregular solid using overflow jar. Overflow jar. How? An overflow jar consists of an iron vessel which is provided with a spout. This is iron vessel. It has a spout. Fill the overflow jar with water till the water is at the point of overflowing. Till the point of overflowing. Just put water here. Under the spout of overflow jar, place a measuring cylinder gently. Lower the solid in the overflow jar. Just place here, so that if water pours here, so that the water comes to this spout and filled in this jar. Okay, place this arrangement like this. The solid displaces water which flows out from the spout into the measuring cylinder. Suppose you again put the solid irregular solid here with a fine cotton thread. Then volume, the level of this water will increase. As it is increased, there is a spout. Already we have completely filled to this point. The extra water will come to here. Here is a measure cylinder. We can measure this volume of this water, and this will be equal to the volume of the object, because the object displaced the water equal to its volume, size of its volume. Okay, this is another way.
You say that everything has a volume, so doesn't the fine thread have a volume, and that also increases?
Yes, that will also increases. Suppose you have a one bucket of water. You just put a drop of water there. Then how much volume will increase? Very minimal. No doubt. The thread has also volume that will impact the volume of the object. It's true, but it's very minimal, so we can ignore it. If the solid is soluble in water, replace water with a liquid in which the solid is insoluble. Suppose you are measuring the volume of salt with the help of water. You put a spoon of salt in water. What will you get the volume of that salt?
Of course.
Of course not. Because when you put salt there, will the level of the water rise? What? Water, yesterday we learned it in our chemistry class, in chemistry chapter. In liquid there are lots of intermolecular space.
And the salt molecules will get between those spaces.
Then will the level rise? If you put no. So in that case, replace the water. What is called solution? Solvent. Replace the solvent. Okay. If so, we have almost covered it.